Sometimes the problems we have to solve are already expanded decimal problems. These are not whole numbers. They are decimal problems already, and you are expected to rewrite them in their ordinary form. Let me show you an example. Take a look at the number we have below. We have this number 0, 0 times 10 to the power of 2, add to 5 times 10 to the power of 1, add it to 3 times 10 to the power of 0, add this to 6 times 10 to the power of negative 1, and add this to 5 times 10 to the power of negative 2. Now notice that their powers are not even. First, here we have positive powers, but for 6 and 5 we have negative powers. This is a very good example of decimal cases. So how would you represent this in their ordinary form? One thing that will help you is your place value scale. To do that, it is important to rewrite each of the place values by the number they represent. So first, let's do that. Notice first that the arrangement is in order. It ranges in descending order from left to right and in ascending order from right to left. So that's okay. Therefore, let's rewrite these expressions thus. This 10 squared is the same thing as 100. So we can write this as 0 times 100. Then 5 times 10 raised to the power 1 can be rewritten as 5 times 10. And 3 times 10 to the power of 0 can be rewritten as 3 times 1. Plus 6 times 10 to the power of negative 1 can be rewritten as 6/10 in fraction form, or it can be written as 0.6 in decimal form. Also, 5 times 10 to the power of negative 2 can be written as 500th or 0.05 decimal. Did you get that? Remember, we are adding all these numbers together. So, first of all, notice on our left hand side or the whole number part that we already have the place values 100, 10, and 1. So I can easily bring that down here, 100, 10, and 1. And this has digits 0, 5, and 3. But on the other part, we have decimal numbers. It means that there's going to be a decimal point right here. What is the place value of the first decimal number? It is the 10th. Can you see that it's 6/10 or 6 upon 10? So which means that the place value here will be the 10th place. And the next one is 500th, meaning that the next place value we have on our right after the 10th place is the 100th place. Okay, since we've already written these, we just have to write the digits representing the places. The digit for the 10th place is 6 and the digit for the 100th place is 5. Remember to bring down your decimal point. So we end up with the number 053.65. Since 0 does not start any number, we can just rewrite this as 53.65. This is the number that has been written in expanded form above. This is clear, I believe that. I think we should take one more example to reaffirm this skill that we have just learned. So I'm going to call the first one example A, while the second one will be B. Our second example should be, let's take this one, 4 times 10 to the power of negative 3, add 0 times 10 to the power of 2, add 6 times 10 to the power of negative 1, add 5 times 10 to the power of 0. You must be careful when sorting this kind of case. Take a look here. Negative 3 is coming first before positive 2. That's not true. Remember your number line. In your number line that can help you, you usually have on the left hand side the negative numbers, so I'm going to call this midpoint to be my 0. On my right side there are going to be positive numbers. Yeah, 1, and this is 2, and this is 3, and it continues that way. While on the left hand side is going to be negative 1, I'm going to have negative 2, I'm going to have negative 3, and the process continues. Yeah, if I was going to write them in powers of 10, it means that this, which is already 0, is going to be the same thing as 10 to the power of 0, since I'm using them as powers. And then on the first one, it will be 10 to the power of 1, 10 to the power of 2, 10 to the power of 3. And then on the left hand side, the first will be 10 to the power of negative 1, second is 10 to the power of negative 2, and the third one will be 10 to the power of negative 3. This is going to help me a lot in dealing with the problems we have right here. Now take a look. The arrangement on the number line is the same pattern we are going to follow to demonstrate a good arrangement of what we have up here. So I'll begin first by rearranging them. Notice that 0 separates the negative from the positive. So if I decide to write the number or the place value with the power of 0 first, which is 5 times 10 to the power of 0, on my left will be the negative one. That is when representing is a number line in order of smallest to biggest. But since it's our place value table we are dealing with, our positive place values stay on the left hand side while the negative one come on the right. Therefore, on this part, I'll be writing numbers that will represent this. Which one has 10 to the power of 1? We don't have anything representing 10 to the power of 1. Take note of that. But we have 10 to the power of 2 as 0 times 10 to the power of 2. Then we have 4 times 10 to the power of negative 3, which I'm going to place here. 4 times 10 to the power of negative 3. What else do we have? There are 4 of them. We have 10 to the power of negative 1. Sorry, 6 times 10 to the power of negative 1, which comes here. 6 times 10 to the power of negative 1. So what it means is that in place of negative 2, there is nothing, 0. In place of positive 10 raised to power 1, there is also nothing. In our place value chart, remember, the highest first going down to the lowest. Since the highest place we have is 10 squared, which means we have the highest one as hundreds place. Therefore, I'll be going down this way. Have 100, tens, ones, point, what do we have? The lowest place that we have is 10 to the power of negative 3, which is the 1000th place. So I'm going to write first 10th, 100th, and then 1000 here. Now we can easily place what we have. Alright, so for the 1000th place, what do we have? The number that stays in the place value of the 1000 is 4, because we have 4 times 10 to the power of negative 3 here. I'll just put the digit 4. In the 100th place, we had nothing, which is just 0. So the digit is going to be 0. In the 10th place, we have the digit 6. Now, point. In our ones place, what do we have? In our ones place, we have 5 times 10 to the power of 0, which is the same thing as 5 coming here. And then in the tens place, we had nothing, so we leave it as 0. Why? In the 100th place, it's also 0, because 10 squared multiplied by 0 is 0. What this means is that both the 100th place and the tens place do not exist. Therefore, this expanded number here is exactly the same thing as the number 5.604. You must be careful when dealing with writing expanded decimal numbers in their actual form, because sometimes it can be tricky. Alright, since we have demonstrated to you now how it is done, you can take a few examples to help yourself master it better. See you later.